We talked last week about describing distributions, and we went through the acronym of SOC. Do you remember this? Hopefully it's still in your brain somewhere. When we do the acronym of SOC, what is the first S? Does anyone remember? What's one of the shape? Okay. What's the O? Outliers or odd features. Okay. What's the C? Center. Very good. And the last S? Spread. Very good. Very good. And so this is going to be talking about center and spread. We're going to get into today, how do you know which measure to use? So when we talk about center, we have three options. We have mean, median, mode. Those are all measures of center. Now we're going to look at which one do you use at what time. So there's going to be a specific one that you should use for each distribution. You don't get to just decide. You need to use the appropriate one for the distribution you have. So that's what we're going to be looking at today, is how do you know which is the appropriate. For the spread, we had range, we had IQR, and we had standard deviation. There's going to be one appropriate one for each distribution. We're going to look at how do you know which one. Okay, so after today, you're responsible for choosing the appropriate one to use when you describe the distribution. So we're going to start over here with the symmetric. So on this side, we first start by remembering what does a symmetric distribution look like. So this one is going to be what you expect when you see that normal looking curve. It's just like what you expect to happen. So basically taller in the middle and slopes off about the same on each side. Okay, something such as this. That's what we're looking for symmetric. So when you have a symmetric distribution, we can compare the mean and the median, and those should be about the same. So if you're looking at a distribution and you're like, I can't really tell. Is it symmetric or is it skewed? I can't really tell. You can look at these two measures. If they're the same, then it's symmetric. If they're not the same, it's skewed. Okay? Now, if you have the set of data, you can find these measures on the calculator, and we're going to do some examples of this. You just hit the stat key, and then you'll go over to where it says calc, and then you choose the number 1, which is 1 bar stats. And when you do that, it's going to give you the mean, median, standard deviation, all the numbers that you would need to know about that data set. So that's our keystroke to get there. And once you get there, the mean is going to be X bar. It'll say X with a line over it. We call that X bar. And that's going to give you a number. That's the mean. The median is just going to be MED. So it'll say MED equals, and then it'll give you the number for the median. So if we have determined that it is symmetric, either by looking at the distribution and the shape of it, or by comparing mean and median, if that happens, which things do we use? Okay, so for center, we're going to use the mean, and for spread, we're going to use standard deviation. So again, on the calculator, this is going to be X bar, and this will be SX. So it's going to give you those values. So why do we choose those? Because these measures take all data values into their calculation. So if we want a really precise measure, we want to take every value of the data set and use it to find how spread out is it, what is the center exactly. So we use mean and standard deviation. But really, it's only accurate if there's no skewness. Skewness will affect the mean and standard deviation, so we don't want to use those in a skewed distribution. Okay, so let's look at what we do for a skewed distribution. So, on the skewed side, if it's skewed to the left, that means it trails off farther on the left. So a skewed left is going to be, I just drew the right. Forget that, I'm telling you, it is Monday. So, skewed left, I just said it and then I drew it the other way. Skewed left, skewed right. So skewed left trails off to the left, skewed right trails off to the right. So what happens is if we have a skewed left, you have to think of it like on a number line. Mean on a symmetric, the mean and median are the same. It's like they're lined up. Okay? It's like they're lined up one right on top of the other. Okay? So they're lined up there. If we take a value and skew it, that means, like on this one, we took a number that should have been closer in and we moved it farther out. So what that does is it pulls the mean over that way. Okay? Because it took a value and made it smaller, so it pulls the mean down. Median stays where it is because that value was already on the left, it just moved it farther on the left. Median didn't change, but the mean got pulled in the direction of that skewness. Okay? So if it's skewed left, the mean is less than the median. Okay? Because it took the value and it pulled it down. If it's skewed right, it took a value and it pulled it bigger, so it pulled the mean in that direction. So the mean is greater than the median. So you can see, this is why we say it's skewed to the left, because the mean moved to the left. It's skewed to the right because the mean moved to the right of the median. It's skewed in that direction. Okay? So this skewness that happens here is why we don't use the mean like we did over here, because the mean got moved because of that outlier or because of that skewness. So what do we use? For center, we're going to use the median. And for spread, we will use IQR. So on the calculator, when you do your calculation, median is the MED. This one, you're going to have to calculate. It's going to give you Q1 and Q3, and we just subtract to get the IQR. So it'll give you the value of Q1 and Q3, and we just do that subtraction to get IQR. So why do we use these? Because these measures are more resistant to outliers and skewness. Because these say, if I have a point and I move it even farther to be an even more extreme outlier, that has no effect on either of these, because these are by where are they in the data set, not what is the value of the numbers in the data set. Okay, so these are more a measure of location, where these are a measure of the value of each number in the data set. Okay, so the middle value doesn't change no matter how far I move that highest or lowest value. The IQR, that middle set, doesn't get affected because outliers are not contained in that middle half of the data. They're on the extreme. So moving them farther out had no effect on that middle part. And you'll see it more as we look at more data, but that's the idea that we're looking at. So these things you need to remember. Symmetric, use mean and standard deviation. If it's skewed, you're going to use median and IQR. Okay. Questions on that part? This idea of resistance is an important idea in statistics. We use it because the outliers and the skewness does not affect these measures. There will be something, I can guarantee you, something on the AP test will be about resistance, because it's an important idea. So we're going to spend some time talking about it throughout the year to make sure you are able to see that. Okay, so let's look at this page, center spread. So this is going to incorporate some of the ideas that we just talked about in our foldable and looking at some data sets. Okay, so this data set we have here at the top came from a set of AP statistics students, and they were asked how many brothers and sisters they have. Okay, and we compiled this data, created this dot plot, and so we're going to use this to calculate the mean, median, mode. So our three measures of center. So if I want to calculate the mean, I'm going to need to add up all of these values and find what is the average. So I'm going to enter these into the calculator. So the way I'm going to do that, stat and then edit. I'm going to clear out the numbers that I have. And so the number of dots for each number tell me how many that I have of that one. So for 0, I have 4 of those. So I'm going to enter 4 zeros. And then for 1, I have 5 of those. And then 2, I have 8. And then 4 threes. There are my values put into the calculator. Once I have entered those, the calculator will find these values for me. Okay? A lot of this stuff that we're going to be looking on here, the calculator will do this for you. So the way I get to that is I go back to stat, over to calculate. This is what we had written in here. Stat, over to calculate, and then I'm going to do 1 bar stats, that first one. My list is L1, that's where did I put my data. Frequency, we're usually not going to use anything for frequency. Usually that will be left blank. And then I'll just calculate. And you'll see it gives you a lot of information. You see this little down arrow? That means there's even more information. When I scroll down, there's more. Now I can scroll back up and see what I had at the top. So this X with the line over it, that X bar, that's our mean. Okay? So I'm going to record that on here for my mean. Usually 3 decimal places is about what we want to see. My median, I just need to scroll down, and there's that MED is 2. Mode it doesn't give you, but you can look at the graph and see which one is the tallest bar, and that's going to be here at 2. So, can we see, what would you say is the shape of this distribution? It's kind of skewed right. And we see that mean is more than the median. Okay? So this is what I mean. Sometimes when you're like, is it symmetric or is that enough to be skewed? You can compare these two numbers and see this one moved higher, so it's skewed right because this number is more than that one. Okay? The more it's skewed, the bigger the difference between the numbers. Okay. So, this 5-number summary, we can see up here our median. We know there are 26. It tells us there are 26 values, and we saw that when we were inputting the numbers. So you could just count this. And that's our median. Is right there. So you could count the dots and find the middle and get the median that way. If we wanted to use the graph to find the 5-number summary, we're just looking for the middle of each side. So there were 13 on this end, then the 7th one. So there is my Q1. And there's my Q3. So I can use those to get my 5-number summary. This idea of 5-number summary, these 5 measures are what we call the 5-number summary. We use this quite a bit. We're going to be using it a lot. Block day this week, and then when we talk about doing the box plot. The minimum value, that's the smallest one, is 0. Q1 was 1. Our median, we already said, was 2. Q3 is at 3. And the maximum is our highest point. Would be at 10. So again, you can start to see that skewness because from the median this way is not nearly as far as the median this way. It's more spread out on the right than it is the left. So that's that idea of skewed right. Okay, so you can see it show up there as well. To get the spread for range, we would do max minus min. So we'd have 10 minus 0 is 10. For IQR, we would do Q3 minus Q1. So 3 minus 1 is 2. Our standard deviation, we're going to go back to where we did our calculation. And this SX, that's my standard deviation. So 2.336. So you can see if we scroll down here, there's our 5-number summary there at the bottom. There's our min, Q1 max, or median, Q3 max. All of those are right there at the bottom. This 5-number summary it gives you on your 1-bar stats. And there are the screenshots in case you forgot how to do those. Enter your data. And this is, we'll write it on here again. This is our stat, and then edit. That's how we got to that screen. And then this, we did stat, and then over to calc. And then we chose 1, which is 1 bar stats. So those are the keystrokes to get to those screens. Questions on the calculator part of that? Does it make sense to you? Okay, on the back side of this, I'm going to talk a little about standard deviation. So if we'll recall, standard deviation measures typical or average distance of the values in the distribution from the mean. So it's good to get an idea of how does this work? Okay, how do they actually do this? So we're going to go through one very simple data set together to see how this works, and then you will not be on a quiz or test or AP exam. You would never be asked to calculate the standard deviation, but you may be asked to explain what it means. Okay, so to find the mean, we just add up our numbers. So we do 1 plus 2 plus 3 plus 4 plus 5, and divide by how many numbers we have, which here is 5. So that would be 6, 12, 15 divided by 5 would be 3. Then we would find how far is each number from the mean. So I want to know how far away is the 1 from the 3. So that's a difference of 2. Here, 3 and 2, there's a difference of 1. 3 to 3, difference of 0. 3 to 4, difference of 1. 3 and 5, difference of 2. Then we square each of these numbers. Okay, so I just do 2 squared is 4, 1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. Then what we do is we find the average, kind of. It's not truly the same as what you would do for an average, but it's sort of the same. So we add the numbers together, and we always divide by the number of things in our data set minus 1. This is the sort of average part. So here we had 5 numbers, but we subtract 1. We always subtract 1 when we divide for our standard deviation. So here we have 10 divided by 4, so 2.5. And then since we squared it here, we want to go back to our same unit, so we unsquare it, so we take the square root, which comes out to approximately 1.5811. So we can see, if I put those numbers into my list, and I did stat calc 1 bar stats, this is the number I get for my standard deviation. So like I say, you need to understand the process of how that happens and what it represents. Actually doing the calculation, you won't be asked to do that. The formula, some people like to know formulas, so here's the formula we would use. We take each value, so the x sub i's, and subtract them the distance from the mean. We squared it, added them all up, divided by n minus 1, and then the last thing we took the square root. So that is the formula. You do not need to memorize it because it's on your formula sheet that you will have for the AP test. You will have this formula sheet whenever we do our quizzes, tests, or anything involving a use for it. So, but it's good to know what it is. Okay, what does it really mean? Let's look at it graphically. So if we wanted to create a dot plot for each of these three, notice here we have 7 4s. So if we create a dot plot, we're just going to stack them up. We just have 7, all of the same value. It's a pretty simple dot plot. If we create a dot plot for this middle one, we have a 2, we have 2 3s, a 4, 2 5s, and a 7. This last one, we have 3 2s, a 4, and 3 7s. So if we're talking about how spread out these things are, if standard deviation is a measure of spread, we should be able to tell which of these has the smallest amount of spread, which would be which one? Which one's not spread out? A, right? Because they're all the same value. We can look at which ones have a bigger average distance from the mean, which ones have more points farther away from the mean. Would be over here, right? Because it has 3 that are far away this way, 3 that are far away that way. So there are more values that are a larger distance from the mean. This one, there are more that are closer to the middle, but there are some that are farther away. Okay? So if we're saying one of these data sets has a standard deviation of 0, which one do we think that's going to be? A. So this one will have standard deviation is 0. It says one has a standard deviation of 1.7 and one has one of 2.5. So between 1.7 and 2.5, which one do we think is B? There we go. So here S equals 1.7. So that means this one had the biggest standard deviation of 2.5. So you're looking at how spread out is it. The more spread out, or the more values that are far away from the mean, the larger the standard deviation. So this is one you saw on your multiple choice Monday. These are very common to see on the AP exam. Which of these sets would have the highest standard deviation? And you're looking for ones that have more values farther away from the middle. That's what you're looking for. If you want to know which one has the smallest standard deviation, you're looking for more values that are close to the middle. So it decreases the average distance. Okay. Questions on this? Okay, so you have this problem set number 15. This just deals with the things that we talked about in the notes today. So you have about 10 minutes left. You should be able to work through this during 10 minutes. So I want to give you guys time to work through it. Let me know if you have questions. You got it. Okay. All right. I will let you guys work.